Hey guys, this is called Section P.7. It's got a really weird name only because the textbook that we kind of follow along, even though you don't have a textbook, this topic is found in some like appendix or something in the book. So it's just got a weird section number. Don't worry about it. But I'm going to show you how to solve radical equations and rational equations in this video. A radical equation is simply an equation that contains some kind of radical. So number 1, number 2 has radicals. Number 3 has a radical in it. Number 4 has a radical in it. And the next set are rational equations. A rational expression, let me put it that way. A rational expression is simply a polynomial over a polynomial. That's what a rational expression is. Polynomial, polynomial. So in this equation, it has at least one rational expression, a poly over a poly. Poly over a poly. Poly over a poly. That's all it is, rational equation. Okay, let's get started. To solve radical equations, you're going to try your best to start by getting the radical by itself. If there's just one radical in the problem, it's usually pretty easy to get the radical by itself. If there are two radicals in the problem, it's going to be tough to get the radical by itself, and I'll show you how to get around that. So, to start off with, I have highlighted this cube root. So I've highlighted this. This is what we're trying to isolate first. Get rid of the 15, get rid of the 2. You see that I got rid of the 15. You see that I got rid of the 2. Here we go. We need, since x is trapped inside a cube root, you need to undo that. What undoes a cube root? Cubing the expression. So we're going to cube this side, and we're going to cube this side. Cubing this radical cancels it out. All that's left is what was currently underneath. And then 5 cubed is 125. Solve it. There you go. The cool thing about this unit is you can take your answers, sub them back in, and check them. Totally encourage you to do that. And you can do this in one big swoop on your calculator. So you can go negative 15 plus 2 times. You've got a way to do a cube root, even on a scientific calculator. If you don't know, ask me later and I'll show you. 2 times whatever we found, 62 plus 1. And when you hit equals, your calculator screen should say negative 5. Moving on. 2 radicals. Okay, you can't get them, you can't isolate them. One's on one side, one's on the other. They're not alike. They're kind of stuck there. So we're just going to go ahead and we're going to undo the fact that these are being squared. So we're going to square this side and square this side. Warning, we're not just squaring the radical, we're squaring the 3 that's in front of the radical. So don't forget the 3. All right, so this cancels this out. That's all that's left. 3 squared is 9. Cancels out. Distribute, blah, blah, blah. Solve. You get x equals 1. Check it. Now this check is a little more complicated. So I got x equals 1. What you would have to do is sub 1 in over here, get an answer, and either write it down or remember it. And then do the same thing over here, sub in 1. Make sure that whatever you got on the right side matches what you got on the left side. Alrighty. Next one. I got one of them. There's just one. Isolate it. So you can see that I got rid of the 5. Square both sides. So I'm going to square this. It's going to cancel out my radical. I'm going to square this. Oh, binomial. You have to FOIL. So I FOILed. Oh, look, it's quadratic. You know how to do those. Set it equal to 0. Try to factor. Set it equal to 0. Oh, yay, it's factorable. I got 2 answers. Positive 9 and positive 2. Thing is, when I plug each of them back in, the 2 didn't work. Only the 9 worked. And keep in mind, this radical already existed on your paper. You didn't decide to like square root this side, square root this side. It was already there. And since it's already there, look what's in front of it. Nothing. So this radical represents the positive root only, not the negative root. How do I know it's not negative? Because there's no negative sign in front of it. How do I know that this 5 isn't negative? Because there's no negative sign in front of it, right? So that's our indication that it's positive only. So anyway, turns out 9 is the only one that works in that equation. All right, 4 is a little more complicated. It's going to take some work. I want to point out how this one is different from number 2. So in number 2, we started with a radical on the left and a radical on the right. But in number 2, hang on, where is it? In number 2, the extra number was attached to the radical. It was multiplied. It's multiplication, okay? There is no plus or minus in there. This is called a monomial. It's one thing glued together with multiplication. Look how that's different from what's in number 4. 2 minus the radical. Oh my gosh, now I have 2 terms. This is a binomial. So when I square both sides, I approach it completely differently than I did up in number 4. Here we go. Square this side, the radical falls off. Square this side, it's a binomial. You're going to have to FOIL. So I am. I'm walking you through step by step. So I went ahead and squared this side. Okay, that was easy. Now, when I go to square this side, what it means is I've got to take this binomial times itself. So I went ahead and wrote them out side by side. I even questioned myself doing the foiling in my head without writing them out. So you'll probably need to write them out. All right, here we go. I got first. Outer, this. Inner, this and this. Last, a negative times a negative is a positive, and the radical times the radical is no more radical. Okay, then what did I do? Then it looks like I said, oh, both sides have a 4. Let's get rid of the 4. Got rid of the 4. These are attached with multiplication, but I could certainly add 3x to both sides. Wow, we're going to have to square both sides again. Good news is, this is a monomial. So when you square this side, you don't have to FOIL. You're simply squaring this number and the radical. Right? Negative 4 squared is this. Square the radical and the symbol goes away. Multiply. Oh, look, it's quadratic. Set it equal to 0. Both terms had an x in there, so I pulled the x out. X is 0 or x is negative 48. When I checked both answers in the original, the negative 48 did not work. Only the 0 worked. So one solution. Okay, that's pretty quick. That solves it. That wraps it up for radical equations. Now let's go to rational equations. I'm going to say something you're going to be like, oh no, I don't want to do that. The process that we're going to go through for these rational equations is we're going to get a common denominator. All right, first of all, our common denominators are kind of messy. We have to get common denominators. Once we get common denominators, the rest of the process is totally easy, I guarantee it. Okay? So the first thing I did is I wondered if I could break down any of my current denominators. Like, can I factor them? So this, I was kind of stuck with. I can't do anything. This one I recognized, oh, look, they both have a 3. So I'm going to pull out a 3. And then this one I couldn't do anything with. So this is my rewrite of the original problem. Ignore the blue for a minute. My rewrite was this fraction stayed the same. This one, I pulled a 3 out of my denominator, and this one stayed the same. Okay? Common denominator. This denominator has a binomial of x plus 1. This denominator has a binomial of x plus 1. Okay, so they already have something in common. Woohoo! But it also has a 3. This denominator has a binomial of x minus 4. I see 1, 2, 3. I see 3 different pieces that need to be included in what's common. They all need a 3. They all need an x plus 1. They all need an x minus 4. So my lowest common denominator has to be the 3, this quantity, and this quantity. So you need to work on getting whatever's missing to each fraction. So you can see that over here, I am missing a 3, and I'm missing an x minus 4. Multiply denominator to get it. Keep it legal. Got to multiply the numerator. This fraction has this, has this. The only thing that's missing is x minus 4. Multiply on bottom, keep it legal, multiply on top. This fraction, what's missing is a 3 and the quantity x plus 1. So multiply, keep it legal, multiply. Now that it's decided what I have to multiply by, now I'm going to do it. And here goes my common denominators. You ready? So, check, check, check. Got them all. Don't multiply them out. On the bottom, do not multiply them out. On the top, go ahead and do your distributing. So, a negative 1 times 3 and put it through. Well, I haven't put it through yet. Next one, check, check, check. Got them all. Don't multiply out the bottom. On the top, 1 times that. Next fraction. 3, this, this. Got it, got it, got it. Don't multiply out the bottom. On top, I'm going to have to, that's a minus sign, I'm going to have to do 2 times 3 times that. Now, here's what's really cool. Here's where it starts to get pretty easy. Once your denominators are exactly the same. See them? Same, same, same. This is an equation. The left side and the right side have to be equal to each other. Well, my denominators are already equal to each other. You know what we need to work on? We need to work on getting the numerators equal to each other. We need to work on getting the numerator on the left side equal to the numerators on the right side. So you can totally focus from now on the numerators. Excuse me. So here's what I did. I just look at the numerators. So I got this and this and this and this equals this and this minus this and this, right? Just grab the numerators. And here's what you get. This was my numerator from the left equals, this was my numerator in the first fraction, minus my numerator in the second fraction. Solve it. Distribute. That one doesn't even need parentheses. Distribute the negative 6. Get all your x's on one side, everything else on the other. X equals negative 11. Woohoo! See how easy it was after we got the common denominators? And then, obviously, plug a negative 11 back in. It looks like it's kind of a pain, but hey, you're going to have a calculator, so go ahead. Take the extra 30 seconds that it takes to plug it in and make sure that negative 11 works. Plug it in over here. See what you get. Either remember it or write it down. And then plug it in over here. Make sure that the right side matches the left side. Okay, next one. Again, we're going to start out by making sure that every current denominator is broken down into factored pieces. So this one is fine. There's nothing I can do with it. This one can totally be factored, and this one is fine. This one's going to factor into x plus 2 and x minus 2. Okay, so left one, middle one I factored, right one stays the same. This one has a binomial of x plus 2, so that's going to be one of my factors in my lowest common denominator. This one already has an x plus 2, woohoo, but it's also got an x minus 2. This one has an x minus 2. So basically my lowest common denominator is going to be one of each. I have to have an x plus 2 and I have to have an x minus 2. I think I wrote that somewhere. Yeah. My lowest common denominator is this binomial times this binomial. So I went back to my expression and said, okay, this one is going to need an x minus 2. Multiply, keep it legal, same to the top. This one is going to need an x plus 2. Multiply, keep it legal, do it to the top. See how they're the same? Once you get your denominators exactly the same, all you have to do is focus on the numerator. So I'm going to write x minus 2 equals 4 minus 1 parentheses x plus 2. The pink is what were my numerators. Distribute, blah, 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 solve it, blah, blah, blah. Oh, man. I got x equals 2. Turns out, when I plug it back in, it doesn't work. Dang. I did all that, only to find out there's no solution. Well, wouldn't have known if I hadn't done all that work. Okay, last one. Don't let this -1 fool you. You still have to get a common denominator. So you look here and you're like, oh, cool. They already have. Yeah, they do. This needs it too. So 7k over 7k to turn this into a fraction that has matching denominators. So I did. Same, changed it. Now that your denominators are the same, you may totally focus on your numerator. So I'm going to write k minus 6 equals 5k plus 40 minus 7k. And then solve it. Got 46 over 3. Ooh, sounds kind of yucky. But you have a calculator, no problem. And your scientific calculators have a fraction button. If you've never used your fraction button, see me. We need to talk. I need to show you how to use that fraction button. All right, I think that wraps it up. Cool. Good luck.